Okay, in example 7, it says in elliptic geometry, how many great circles can be drawn through any 2 points? Interesting. We've kind of talked about it if you listened to me last day, but I will quickly draw it here because it's going to help us in part 2 of the example. So we have some sphere. Obviously I don't draw as good as the description. Then we've got the equator on it. We can call that the Earth. Okay, and there's a center here. Okay. It's not letting me draw it. Let me draw the center there without trying to do something else. Put the center there like this. Okay, there's the center in yellow. Okay, and what I've drawn is a great circle because it's the largest circle possible. It always includes the center, and there's many great circles there. So it says how many great circles can be drawn through any 2 points. So if I take my pen and I draw some other points, and now these are on the surface of it. There's one, and there's another one right here. Okay, well, it turns out that I can only draw one great circle through any 2 points. This is behind on the other side, I can't see. I can only draw one great circle through there because remember, a great circle is on a sphere is the same as or similar to a line when you're talking about a plane. So in Euclidean geometry, any 2 points contain a line. In spherical geometry, or more generally elliptical geometry, any 2 points contain only one great circle. So that answers part 1. Now part 2 of that says, suppose points A, B, and C are collinear. So in other words, what they're saying is they're on the same great circle. So I have to draw another point here. And I'm going to put it right here. Okay? So I've got A. Oh, that's lame. So I've got point A. I've got point B. And I have point C there. Okay? And it says here, and I put them in that order. Suppose points A, B, and C are collinear. That is, they lie on the same great circle. So I said that already. If the points appear in that order, which point is between the other two? Now let's think about a line. Okay, if I put them in an order, A, B, C, A, B, C, which one is in between? Well, clearly B is in between. Okay, but let's look at that great circle, depending on where we start. If we start at A, let's go back here first. If we look here, B, if we go in order, it goes A, then B, then C. And so the second point we meet is in between. Or if we go the other way, C, then B, then E, then A, you're back to getting B in the middle, or in between them. So let's go back to our great circle. And we said if we start at A and go around one way, so I went to the North Pole, down to the South Pole, I'm hitting C as second, B is third. So if I go in that direction, if I go in this direction this way, towards, if I go in this direction towards the North Pole first, I'm going to say C is between. Okay? What if I do the other direction? What if I start at A and I go through the South Pole first? So I'm going to trace that with a different color, though. I'm going to do that in red. Start at A, go down South Pole all the way to the North Pole and back to A. And it turns out that I hit B first. So if I go that route, then B is between. So I have the direction matters which way I go, because the great circle, or a circle, doesn't really have a beginning or end. So the answer is, if the points appear in that order, which point is between the other two? Well, it doesn't matter. The answer is they all are between each other. Because it depends where you started. If I do the same argument but I start at B this time, and I go North Pole, South Pole, and back to B, I get A in between. And if I start at B and I go South Pole instead and go South, C, back up to here, I'm going to get C in between. So now both are between again, and so I got A and C between. So it depends where you start, it depends where you end. So they're all between each other.